Okay, so the today lecture topic is hypothesis testing. So as you people know that until now we have just covered the portion of descriptive statistics. As in the start of this course, I have already discussed in great detail that there will be two types of statistics. One is descriptive and one is inferential statistics. So hypothesis testing is basically a part of inferential statistics. So what is hypothesis testing? If I generally discussed with you the definition of hypothesis testing. So basically this is an act in statistics whereby an analyst, statistician or business analyst test an assumption regarding a population parameter. The methodology employed by the analyst depend on the nature of the data used and the reason for the analysis. So basically when we want to conduct some statistical analysis based on the population data. So population data will be very huge data. We wouldn't be able to inspect, let's suppose if we want to inspect a specific product in a company, it will be very difficult to inspect each and every product. Maybe they're producing in thousands of those products. So it will be difficult. So how we will pass the quality of their production? So you need to randomly select a sample size, a sample from that big population, and then on the basis of that population, you will decide that should we need to accept that production, should we need to accept that quality or not. So in this portion, I will discuss the hypothesis testing. We will discuss type 1 error, type 2 error, which is also called in statistics alpha, beta, etc. Then we will take it to the different mode in hypothesis testing, just like the standard normal distributions, student t distribution. Then we will extend it to the F statistic, chi-square statistic, and at the end we will cover the analysis of variance, which is called ANOVA. So starting from the hypothesis testing logic, hypothesis testing is one of the most commonly used inferential procedures. So as I already mentioned that this is an inferential statistic type, a statistical method that uses sample data to evaluate the validity of hypothesis about a population parameter. So as I already mentioned, that means we wouldn't be able to inspect, we wouldn't be able to check each and every part of that population, which is very big, which is very huge. So that is why we will take sample data, then on the basis of that sample data, we will discuss, we will accept, we will pass the production of a specific company, of a specific production unit, or we will reject it. So hypothesis is about a population and predict the expected characteristic of the sample based on the hypothesis. So basically what we will do, we will take a random sample from a population and then we will expect those characteristics, and on the basis of those attributes and those expected characteristics, we will discuss the results on the population. So it compares the obtained sample data with the prediction made from the hypothesis. If it is consistent, then the hypothesis is reasonable. If it is not, hypothesis will be rejected. So just want to give you a simple example. Please note this example. For example, a person wants to test that a coin or a penny has exactly a 50% chance of landing on head. So basically a coin have two possible outcomes. One is head or one is tail. So now the person has exactly say that there is a 50% chance, then when I flip this coin, 50% chance will be that it will be the number appear, the shape appear on the coin or the penny will be a head. So in this case, the null hypothesis, because there are two different parts of types of hypothesis testing. One is called null hypothesis and the other is called alternative hypothesis. Null hypothesis means that I say that the penny, when I throw it, there is a chance that 50% chance that it will be a head. So in this case, my null hypothesis will be yes. Yes, it will be 50% chance that you will get a head. So what will be the opposite of this? Basically, alternative hypothesis show an opposite of the null hypothesis. So the alternative hypothesis would be no, it does not land on head. So when it is not land on head, it will be definitely a tail. Mathematically, the null hypothesis would be represented as, so normally we represent null hypothesis with H naught, subscript H naught, okay. So the probability of this will be, let's suppose, because the probability of getting head is 0.5 and the probability of getting a tail is also 0.5. So the opposite of the alternative hypothesis will be no, it will not be a head, but it will be a tail. And normally we denote alternative hypothesis with H1 in subscript, or we also write HA. So you can write it on both ways. And be identical to the null hypothesis, except with the equal sign struck through, meaning that it does not equal 50%. So in null hypothesis, if I just write it, that when we flip a coin, it will be 100%. There is a chance that it will be the null hypothesis. There is a chance that it will be, probability will be, it will be 5% or 50% a chance that it will be a head appear. Alternative will be, we normally denote with 1. Alternative will be, no, it will not be equal to head or 0.50. So if it is not 0.50, maybe it will be 40% when you throw 100% a coin. So there will be a chance that 40 times you will get only a head. So the remaining will be 60% time that you will get a tail. So at this way we will interpret the hypothesis. Let's suppose a random sample of 100 coin flip is taken and the null hypothesis is then tested. If it is found that the 100 coin flip were distributed as 40 head and 60 tails. So let's suppose we random sample, because they claim that there is a chance that 50% you will get head and 50% you will get tail. But now in a sample, we just want to conduct it, is the claim is right or wrong. So we just take a random sample of 100 coin flip. So 100 times we toss the coin and the null hypothesis is tested. If it is found that the 100 coin flip were distributed as 40 head and 60 tail, the analysis would assume that a penny does not have a 50% chance of landing. So in this case, our null hypothesis is not 50% and would reject the null hypothesis. So what we will do, because we found that only 40% a head appear, so we will reject our null hypothesis and accept our null hypothesis. So we will accept this null hypothesis. If on the other hand, there were 48 head and 52 tails, then it is plausible that the coin could be fair and still produce such a result. In case such as this, were the null hypothesis accepted, the analyst or the person who doing this job state that the difference between the expected results 50 head and 50 tail and the observed result 48 head and 52 tail is explained by the chance alone. So at this way, basically this is just a simple example which I shared with you. So at this way you will interpret what is null hypothesis and what is alternative hypothesis. Why we need this hypothesis testing? So this is very interesting question. What is the purpose? Why we need to conduct this hypothesis testing? So the purpose of hypothesis testing is to determine whether there is enough statistical evidence in favor of certain belief or hypothesis about a parameter. For example, that most of the people not believing that the COVID-19 is a real pandemic. Let's suppose this is just the general perception about the population of Pakistan, let's suppose. So now we will check, because in Pakistan we have a huge, because Pakistan is a huge populated country, so it will be difficult to ask from every person there, would you believe on this COVID-19 that it is a real disease? So what we will do, we will just take a sample from different locations, from different provinces, and then on the basis of that we will say the null hypothesis be, yes, they believe that COVID-19 is a true disease, is a true pandemic, okay, and the alternative will be, no, they not believe, let's suppose. So when we collect the sample data, so on the basis of that sample data we will be predicting about the whole Pakistan. So basically in hypothesis testing we collect data in a shape of sample size and then they explain the whole behavior of the population. So there are some more examples I'll just mention in order to further clear you the purpose of hypothesis testing. Is there statistical evidence from a random sample of potential customer to support the hypothesis that more than 10% of the potential customer will purchase a new product? So now at this way you will interpret the hypothesis to support hypothesis that more than 10%. So how you will write more than 10%? Now this is a little bit sign of alternative hypothesis, because I will also discuss with you that in null hypothesis and alternative hypothesis, in null hypothesis we will use the sign of equality. In null hypothesis we will use these sign which I will also discuss. We will use the sign equal to, greater than or equal to, less than or equal to, and alternative will be the opposite of this sign, not equal to. If it is greater than or equal to, it will be less than, okay, the opposite of this one. If it is less than or equal to, so it will be greater than. So always we will use the opposite. If it is equal to, we will say no, this is not equal to. If it is greater than or equal to, so now they say that more than 10% of the potential. So this is basically the ideology of the alternative hypothesis. In a new drug effective, in a curing a certain disease, a sample of patient is randomly selected. Half of them are given the drug, while the other half are given a placebo. Placebo means normal medicine, which is not specifically for that disease. So the condition of the patient are then measured and compared. So basically all these are the different purposes for which we will not be able to do a descriptive statistic for this purpose, because we need to collect some sample data, and then on the basis of that sample data we will decide to accept that statement which they raise for it, or we will reject that statement. In order to further clear the example, I am just going to show you a simple example.